Hi, I'm Tom Stephenson and welcome to my YouTube channel. I'm a professor of construction management and I have a series of videos on this channel, everything to do with construction management. So you can always check my playlist to see different orders of different types of videos. This series is based on my textbook, Understanding Construction Drawings. So I'm going to be highlighting key points of the various chapters in Understanding Construction Drawings and going through it to make sure you fully understand it. I'll put a description and a link to the textbook in the description below, and so if you want to purchase it, you can go ahead, but you don't have to have the textbook to be able to benefit from this series of lectures and videos. So let's get started. Today we're going to be looking at measurement systems and scales and how that is utilized on construction drawings. I live in Toronto, Canada, so we in Canada use two systems of measurement. We use the Imperial system, feet and inches, and we use the metric system. So I'll be going over both types of scale so you can compare and contrast. Wherever you are, you're likely using one of those two systems, okay? So we'll be going through that. But more importantly too, I want to make sure we understand the concepts of drawing to scale. I want to make sure that basically you understand how to interpret the information you found on the drawings that way. I'll talk a little bit about tape measures and things like that and make some comparisons to like a tape measure and a scale and how that kind of works. And in the next video, we'll be looking at various line types. I will provide links to the previous videos below in the description, and as I keep adding to it, you'll see there'll be a whole playlist that'll be collecting with all of these videos in it. All right, so let's take a look. So scale refers to basically the enlargement or the shrinking down of an object. You hear the term scaling, or is it scalable, used in the business world. Like, how scalable is this? Well, it's taking something small, like a small business entity, and making it big, right? In the digital world, it's pretty easy to really scale companies if you've got a really good product. Well, in the construction world, we're trying to figure out, well, we've got this building, and how do I fit it on a medium that people can read it and understand what it is that we want to construct? So we call that scaling. We're going to basically reduce the object scaled to fit our print medium if we're using print, or our digital medium if we're using digital. And so everything is scalable. I was just pulling this up before the video, but basically everything is scalable. You take a photo on your phone, right? You take a photo, it's proportionally smaller. If I want to zoom in and make something bigger, I can, right? So that's just scaling it bigger, smaller, but the real life is much bigger than that. So that's what we're trying to do. So as I said, a photograph, a map is the same deal, right? Like, how do I fit this city on one page of a map, or on my phone if I've got Google Maps or Waze, etc. So anytime you draw something, you sketch something, you're drawing it to a scale. The difference is construction, we try to do it to a pretty accurate scale because it's important, because we want to be able to see if there's problems with this building. And part of that is when we're actually putting together and designing the drawings, that we see these problems and then we can make adjustments. So a consultant, an architect that's putting things together, they're looking for things like that are what they call interferences, something that might get in the way of something else, right? And so if it's not to scale, well, what are you really looking at? You don't really know. So that's why it's very important as well. So this type of scale and the amount that we're going to scale it down is really based on, like I said, if we're talking about print, the size of the paper that we're putting it on, because we have to scale it down enough that the building fits on the print medium that we're using. Like if we're using an 11-inch by 17-inch sheet of paper, we want to make sure it's scaled small enough that it fits on that, but not too small that it becomes hard to read. So that's where it comes down to, like, what size paper we're going to use is kind of dependent on the size of the building that we're doing. And when we scale it down, without scaling it so small we can't understand what it is important, right? And so it'll either be metric or imperial, like I said earlier. The two systems, they're very frequently used. In Canada, the problem is we use two systems. If I want to be pretty straight up, it'd be nice if we only used one system, because whenever you use two systems, it's extra, right? But our building codes, totally. Anything government, totally metric. And if you know Imperial, it's fairly easy to learn metric. Pretty easy. If you know metric, it's a little bit harder to learn Imperial for the simple reason you might ask yourself why. Like, why is this like that? Why is that like that? Whereas metric, if you understand the system, it just makes a lot of logical sense. So you're just moving decimal places and things like that. I grew up with the Imperial system. We switched over as a country to metric, and I still think very much in Imperial, even though metric is easier, right? So, it just depends. I often imagine that's kind of like English as a second language. You're converting stuff back in your head to your home language. So, yes. So in Canada, too, we got a mishmash of things. Like our building code is metric. If you buy a sheet of drywall or a sheet of plywood, just exactly like the US, 4 foot by 8 foot, 1/2 inch, 3/4, 5/8, typical thicknesses that you would find in sheet goods. Blocks, however, no, they're metric. And I think the key reason is that, tariffs aside and other things, the key reason is that we tend to ship 10 times the goods to the US that we use here because the US has 10 times the people, right? And we're right next to each other. So that is the reason that we pretty much stick with Imperial measurement for things like drywall and plywood. Blocks, I don't think we ship a lot. So they are actually metric. The funny thing is, very often with blocks, we'll say, you'll go into a building supply and you'll say, I want 300 6-inch blocks, right? They're not going to give you 6-inch blocks. They're going to give you 150 millimeter blocks because that's what they are. They're metric. It's close. It's very close to 6-inch blocks. And nobody will say anything. They'll just give you the metric block. So you have to get kind of used to that there's these differences. Here's an 8-inch block. This is 7 5/8 high. Well, the reason it's not 8 inches is there's 3/8 of an inch left for a mortar joint. This is the old Imperial block. If you do renovation work and you're tearing out an old building and it was built before 1976, 77, the blocks in it, you'll see 3 core holes. The 3 core holes represent basically that it's Imperial. When they switched to metric, they only went with 2 core holes for whatever the reason. It's obviously it saves a little bit of concrete, and I guess the design of it, maybe some of the webs were a little bit thicker, strength-wise, it's fine. So this is 190 millimeters. It'll lay to 200 millimeters. 200 millimeters. So it's close to this. 200 millimeters is not quite exactly the 8 inches. It's slightly less. And if you're a block layer and you're trying to match them up, they wouldn't match up. But it's just enough to make a difference. Okay, so you got to know different things, different materials. It's kind of goes from one system to the other, and you get used to it, right? You get used to it. It's just something that you deal with here from that perspective. But it's good to know, right now, this is worth it right here. If you do any kind of renovations, if you're trying to match into an older house block, it's not going to be a perfect match. You got to know that part of it. All right, so that's very, very typical from that way. And like I said, our building codes, they've been starting to change on some of them. I think the NBC or the National Building Code of Canada or the Ontario Building Code of Canada, they're starting to switch over to like the actual size, but traditionally they've all said 300, 400, 600. This is standard spacing for your studs and your joists. We'll unpack this in future videos, but your studs are the vertical members in a wall. And so they're standardized at certain measurements. So even though our building code would say this, and even though this is not exactly 12 inches, 16 inches, 24, this is what it exactly is, we would see this on a drawing and it's fine to lay it out at that. We'd see this on a drawing and it's fine to lay it out at that. And you would lay it out at that because you want your drywall, which is 8 foot, to align with 16 inches on center, because the idea is the studs line up with the sheets so that when you put a sheet on, at the end, it'll be halfway on the stud, so you can put the next sheet on and not cut it. Plus the fact that all of our structural calculations and everything are based on these standard spacings, right? All our standard like friction fit bats of insulation are cut to that so that it nice and fits in. So all of these things kind of go together from that perspective. All right, so if you see this in a Canadian building code, then you got to know that on the site, it would actually be laid out to this. In the US, you wouldn't have any problem. It would just be this and you're good. Right, so you have no worries with that. That actually makes it simpler from that perspective. So a typical tape measure, now this is a metric imperial tape measure, so it's got both measurements so you can compare. Here's basically a imperial measurement, and you notice along the bottom they've got the fractions of an inch, right, listed. I'm finding they're starting to do that more on tape measures. I guess it's because they're finding some people are having trouble reading the fractions of an inch. Truth is, once you get used to it, you shouldn't need to have it written there, but that's fine. It's there. On this one up here, you can kind of I can compare to you that there is a difference. Like there's 16 inches on center, there's 12 inches, so you can see this is a little bit less, right? And then of course at 600, it's twice as much less. And you know, if you went to 900 or 90 centimeters, 900 millimeters, it would be 3 times as much. So by the time you get to 8 feet, it's quite a bit different, right? Our standard spacing, all of them divide evenly into 8 foot. The most standard spacings are 12, 16, and 24, and they even divide evenly into 4 foot. So basically the width of a sheet of plywood as well, or drywall. You may find this diamond on some tape measures, the better tape measures, and the diamond is for 19.2. Why 19.2? Well, 19.2 seems like a crazy number. It divides evenly into 8 feet. So it's another spacing that divides evenly into 8 feet. 8 feet is 96 inches. 5 times 19.2, 96 inches. It allows a little bit more flexibility. One of the big home builders that I used to do a lot of consulting work with, Manami Homes, at one point they were doing a lot of houses, I'm not sure if they still are, at 19.2 on-center stud spacing. And the logic there was 19.2 is we will use fewer studs. Okay, we'll use fewer studs on a home. I don't know, if it's 50 studs on a home less, and each one's $6, that's $300 in a home. That's a nice little savings. May not seem like that much, but if you build 6,000 or 7,000 homes a year, it makes a difference. But beyond that, it was actually, it was very interesting. It wasn't really, that wasn't the core reason they were doing it. The core reason that they were doing it was, well, they were upping their game at the time for Energy Star home certification. And it's a more energy efficient house. You've got less thermal bridging through the studs. And they were building with 2x6s, not 2x4s. We, for years, built with 2x4s, but we went to 2x6s so we could fit more insulation and meet new building code standards for high R values. R values is resistance to heat loss through the wall. And so you've got fewer studs. Studs are not as energy efficient as insulation. That makes sense. And so you're actually building a more energy efficient home that way. So, and you're cutting down less trees. So you put all these things together, that's what you would call optimum value engineering, where, yeah, you're saving some money, but you're also making a more energy efficient house. You're not structurally compromising it. Like when you consider we used to build with 2x4 houses, we're building with 2x6 houses. So very good concepts. There's these little concepts that are in and around all areas of construction. And, you know, if you make this, that you start to learn some of these concepts and take advantage of them, you're very valuable to your employer. You develop a competitive advantage when you're trying to get jobs, etc. So there's a lot of pluses to kind of thinking on that continuous improvement mindset. So this is where I was saying the measurements, right? And so the other thing I wanted to mention is like, all right, and this is even telling you 1'5", 1'6", 1'7", right? Which is the same as 18 inches. 1 foot is 12 inches. plus 6 is 18. This is all it's doing for you on this type of tape measure. Some of them, they don't do that, right? Like, so basically it just depends. This one's trying to really help people out, in my opinion. So I use it just so that maybe I can use it as a teaching tool from that perspective. You'll usually find most of them, well, even this one kind of has it, but you know, it's a little bit different. It doesn't have the fractions there, not as clearly as and what is a foot and what is inches, etc. But this is more standard stuff, right, as far as what you'll see on a tape measure. So yes, it says the actual fractions of an inch. So that's the challenging part about Imperial, right? Fractions of an inch bother people that aren't used to them. If you're used to decimals, then it's just like, this is easy. Fractions, it's like, generally, you'll find they will be to a 16th of an inch. So what that means is from 1 inch to the next inch, it will be divided into 16 spaces. All right, so you have 16 spaces from one to the other. And usually they will change the length of the lines of the bars to give you a clue. Like I know when I look about halfway, I'm going to see a longer bar, and I know that's exactly half an inch. And a half an inch is 8/16. All right, going back to grade school, 8/16, right? That's basically, if we want to reduce that to lowest terms, that's going to be half an inch. Okay, and then we know that this next length of bar, it's going to be halfway between, you know, the starting point 0 and a half an inch. And so that's got to be a quarter of an inch, right? 2 quarters make a half, so that's a quarter. Well, a quarter has 4/16. 4/16 reduced to lowest terms, 1/4 of an inch. And then we've got here, this is a quarter of an inch, that's an eighth of an inch, right? So that's half of a quarter is an eighth of an inch. Okay, and then half of an eighth is a 16th. So each space is a 16th. So 1, 2, 3, 4, this would be 5/16, right? This would be 6/16, which is 3/8, all right? So we would talk about that in terms of 3/8 of an inch. This is here, half an inch and 3/4. This would be 5/8 because this is 4/8. This is 6/8. So that would be 5/8, right? So we know, and we know that this is 8/16, so that's got to be 9/16. And so that's basically how we can sort of move things across. This is showing in eighths, quarter, 3/8, half, 5/8. And that's usually, if I'm doing a measurement and I'm calling it out to another carpenter to cut something, I might say, I need a piece that's 18 and 5/8 long. If it's 18 and 5/8 long, I would go there, right? To that point there. Or I might say I need a piece that's 18 and, I said 18 and 5/8 long. So now I'm going to say 18 and 9/16. 18 and 9/16 will be right here because that's 8/16, that's 9/16. A little trick that a lot of times carpenters will say is, I want 18 and a half full. That pretty much is like saying almost 9/16. Like that's usually, they're just saying just a little bit more instead of yelling out 16ths. But this is basically your sizing for your pieces, right? And you might say, if you wanted something slightly less than a half an inch, they might say 18 and a half light. You know, again, they're regionally and things like that. There's always these little nuances. Put in the comments if there's something that you know that's a little bit different in your region for that sort of stuff. So let's talk a little bit with metric. All right, so this is your metric scale. And metric, like I said, is fairly easy to explain, especially a metric scale. If it says 1 to 10, it means it's 1/10 of the full size. That's basically it. So 1/10 full size. So this is representing 100 millimeters. If I put 10 of that size together, that would give me what 100 millimeters is in real life, which is just slightly under 4 inches if you're on the Imperial side. All right. So it's already scaled. That means I could just, if the drawing is drawn to 1 to 10, I could just lay that scale on the drawing and read it, and that will give me what the measurement is supposed to be. I'm going to talk about caution with scales later on. Like, don't go running around scaling drawings and then building stuff from the scale, because on the drawings it'll usually say NTS, not to scale, and that's the consultant architect covering themselves. They don't want you scaling the drawings. If there's a missing measurement, you should ask them. But on the other hand, if you're estimating something and you need a quick measurement, or you can't get anybody and you need to rough this out and you know you're taking responsibility, then that's okay. More importantly, too, is just understanding how everything is reduced proportionately and what the standard scales are. The scales will be, what the scale is supposed to be, will be in the title block of the drawing. All right, so you look for the title block and it'll tell you what the scale is. So this is like typical scales, anywhere from 1 to 250. That's 1/250th full size. So on some site plans, that might be a big site plan that you're trying to fit onto a piece of paper, maybe a plat plan. Plat plans like for a whole subdivision, it might be really reduced, right? So that's where you might see 1 to 250. Floor plans, very popular one, is 1 to 75 or 1 to 100, 1 to 50, in that kind of zone. So there's different ones used for different things. Very often, once you pick one for drawings, even these will be probably 1 to 75 or what have you, just that it fits, right? 1 to 1 is just full size. So whatever you're drawing is something small then. Maybe it's a zoomed in detail or something like that. Just to give you a hint, 1 to 1, so that'd be 130, 135. That's just a regular measurement. That's a regular measurement. And the reason I talk about tape measures is for those of you that have trade backgrounds that are maybe taking a course or something and you're being taught stuff about scales, it's harder for you, I think, than somebody who isn't, because you're used to looking at a tape measure and a 16th is always a 16th. A quarter is always a quarter. 5/8 is always 5/8. It's always kind of broken up the same way, and you know that one way. With scales, it changes by the scale. And there are these scale rulers. And what the scale rulers do is they've got these scales printed on them. And so one ruler, right, may have 6 different scales on it in metric. In Imperial, I forget, it's like 2, 4, it's like something like 11 or 12 scales on one ruler. So that's a lot, right? And that means you got to adjust every time you look at the scale for what it is. 1 to 2 basically means it's basically half of the full size, right? It's half of full size. So it's not reduced that much, but it is reduced, right? So it's half of full size. So if I take basically, if that basically is full size, 10 millimeters, which it is, then basically that's 10 millimeters, right? So you see how that's now reduced because that's half of full size. 1 to 5 is 1/5 of full size. So it's reduced more. Like look, 100 millimeters is over here, right? So 1/5, 100 millimeters is over there. Over here, 100 millimeters is way down there. Like 100 millimeters here is lining up with 20, right? So that's 1/5 because 20, there's 5 20s and 100. That's how it's working. 1 to 50th, 1/50th full size. And the little hint I'm going to give you with metric scales is usually, but I would always check it. Usually that means, like here, each tick means 1 millimeter. Here, each tick means 2 millimeters. Here, each tick means 5 millimeters, okay? And if you're not sure, all right, well, you could think that's 5, that's 10, 15, 20, 25, 30, 35, 40, 45, okay, 50. That makes sense. That should be 50 because that's halfway between 0 and 100. Okay, so 1 tick is 5 millimeters. I'm verifying it. 1 to 50, all right, so that means that 1 tick is 50 millimeters, right? So that would be 50 and 100. If I just look at that, that's 100. Well, that would be 200. That would be 300. That would be 400. That would be 500. That makes sense. That's 500 millimeters. 500 millimeters is half of a meter, right? And so if that's 100, then that's 50. Yes, each tick is 50 millimeters. You just got to figure it out. And then once you know it, and if you're using a particular scale, then you can utilize it that way, right? So 1 to 5, if I'm reading this, right, that would be 136 millimeters. So this is 100, 10, 20, 30, 35, and it's just slightly longer than that. So that's where I'm getting the 136 from. The truth is, when the more the scale gets reduced, as you can tell, the harder it is to be really accurate. That's why consultants will say not to scale, because they don't want you scaling things and something doesn't fit or something doesn't work. They'd rather you get a confirmation from them on what the scale is. But with that said, you know what? Like if I'm doing an estimate and I want to know, are these 16-foot 2x8s that I need, or are they 14-foot 2x8s? You should be able to tell, okay, no, I'm going to order the 16-footers, right? Because it looks like it's probably going to be about 16-foot 8, or sorry, 15-foot 8. So I'm going to order 16-footers, right? So it's good for that stuff, definitely. Okay, let's talk a little bit about metric. Sorry, not metric, imperial. Okay, so we got the imperial side, and there's an imperial scale, right? So this is in feet and inches. So what happens in the imperial scale, this is the confusing part. And in the textbook, I've got a bunch of exercises that you can try, and there's answers, and you can see how you're doing at reading them. But basically, you are at the end, you have a measurement, right, that you can sort of see. And that measurement at the end is always going to represent a foot. So this always represents a foot. This always represents a foot in real life. It's scaled down, and it means 1.5 inches equals a foot in real life. So if I've got a line on my drawing that is basically 3 inches long, right, that would using a 1.5 inch scale, that would represent 2 feet in real life. That's how it works, okay? It's not as intuitive as the metric scales are. The other thing is they save a lot by running one scale from this end going that way and another scale running this way, but then it causes confusion because you get stuff like this going on. Like that says 2, so it should be 2 feet, shouldn't it? How come he's got 1 foot there? Well, because it's coming from the other side, and when it's coming from the other side, there's another measurement, there's a 3-inch scale on the other side that's coming this way. So what you got to look at is, where is the 0 here? Oh, it's there. Okay, so that's referring to this one. So that's actually 2 feet. Anything that's over your measurement, like 1 foot something or 2 foot something, the odd amount will be landing over here so that you can get a measurement from it. So a line on your drawings that you're trying to figure out, how long is that? If I lay this on it, well, that's 2 feet, but I would use this one to count as 1 feet because it'll be half, whatever that is. All right, and I can visually see that that distance is the same as that distance. So I know, okay, that's 1 foot. All right, so that's 1 foot. And then this will always represent a foot. So this represents then 3 inches, 6 inches, 9 inches. If this is 3 inches, then that's got to be 2 inches, and that's got to be 1 inch. If that's 1 inch, then that's got to be a quarter, a half, 3/4. 1 inch, a quarter, half, 3/4, an inch, a quarter, right? So that's 1 foot, 1. So 1 foot, right? 1, 2, and a quarter inches. 1 foot, 2 1/4 inches. Dimension line, extension lines telling us the size. All right? So that's basically how we can sort of read an imperial scale to get a good understanding. And you can see on this one, like that's placed, that would be full size. So if you're a tradesperson, this is the one you like because it just looks like your tape measure. But this one here has a 3/32 scale and a 3/16 scale. So the 3/32 scale is going from this direction. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8 feet. And see the little tick there? That's 8'6". It's very small scale, so very reduced, right? So you can be very off pretty quick. Coming from this side, okay, so this is using the top one. Well, if that's 2, then this has to be 1. So I only care about every foot increment. 1, 2, 3, 4, 5, 6, 7, 8. And then this represents a foot, so that's 6 inches. That little tick there is 3 inches. Those little ones that you can barely see are basically an inch. Okay? Now, just like the metric, the 3/32, like I said, is very reduced. In this case, that's about 1/128 full size. 1/8, 1/96. How do I know 1/8 is 1/96? Well, how many eighths are there in an inch? 8. How many inches are in there a foot? 12. 8 times 12? 96. So it's 1/96 full size. That's how you get that, right? How many quarters? Well, 4 quarters in an inch. How many inches in a foot? 12. 4 times 12, 48. 1/48. This would be comparable, but not exactly, obviously, different measurements, to the 1 to 50 in metric, to the 1 to 100 in metric, right? And so it has the different scales. Very common scales that you'll see are 1/4 inch, 3/16 inch scales. Very, very commonly used, those two, right? And it kind of gives you that sort of overview there and how that works. So you can see here, you've got here 1 foot, 2 foot. This is 6, 7 inches, right? Using the 1.5 inch scale. Using the 1 inch scale, 1 foot, 2 foot, 2 foot, 6, 7, because that'd be 8, that'd be 9, right? So you're just looking at it, you're breaking it down. What does each measurement mean? And that will give you sort of those kind of comparisons there. If I was to look at this one here, number 1, right? I'm looking at that. Okay, that distance there is 1 foot, and then you got another foot. Okay, so that's basically going to be here. That's going to be 2 foot. And I'm going from this extension line to this extension line. Reading drawings, you get used to that, right? 2 foot, 9. Well, if that's 9, this is 10, that's 11, that's 12. Okay, so if that's 9 and that's 10, that's 9.5. That's 9.5, that's 9.25. So this measurement number 1 would be 1 foot, 2 foot, 9.25 inches. Number 2, it's going here, right? That's 1 foot, 2 foot, 3, 6, okay, 4 inches, because that's 5 inches. And that's in the middle. So that's got to be 2 foot, 4.5 inches. 2 foot, 4.5 inches. So step by step, you always break it down to try to read it and figure it out. So you're basically laying this on a drawing. And so this particular drawing was done to 3/16 of an inch scale. If I wanted to see if it was actually to scale, right? If I wanted to see if it was actually to scale, what I would do is, like, because sometimes you can have that the drawing was enlarged or it shrunk, a series of things that could have happened. You can check it to see, well, is this pretty good? Because this has a measurement here. And you could lay it down and you could say, okay, I'm using a 3/16 scale, right? So there's 2 foot, that's 1 foot then. There's 2 foot, there's 4 foot, that's 3 foot. Okay, 12, 14 foot. So coming from this line, 14 foot to this line here, I just overdid it in red. Okay, that's 6 inches, right? So it's coming in at about 14 foot, like right, it's maybe a little blurred there, but right where it's crossing over here, that's at 14 foot 9 inches. So I'm going to say it's plotted to scale. I can check that and I know. So if I wanted to kind of get a measurement from here to there, I should be able to move the ruler and scale it from there to there and get a pretty good idea of where that is. Again, though, I'm going to emphasize I wouldn't be doing it for any kind of important measurements, but I would do it if there's something I need that I can't get a quick answer to, or if I'm doing a measurement to say, how long do I have to order these pieces of wood, right? Do I need 8 footers or 9 footers or 10 footers if we're talking wall heights or something? I might use it for that. So that's where it's very useful. And that's how a scale is used. Now, we have digital scales that if you're using a program like Bluebeam or Revit and things, you can easily get measurements, take measurements from those drawings digitally, right? You do have to have the software and you do have to basically know how to use it, but you can easily pull off, like estimators for the most part, they're not manually doing things anymore, right? Unless it's something quick or something being ordered from the site super, or it's a checkup of a measurement, you are very often doing these things. But it's just to give you also a good sense of how everything is proportionately down and how this building is proportionally bigger. It's very important to visualize that and to be able to understand that so that you know how that works. Before you even think about doing things from a digital scaling point of view, you got to understand those concepts. So yeah, so reasons it's not appropriate to scale drawings is photocopying. Like you could have a photocopy of a photocopy of a photocopy. So that's why you want to check it, like I just showed you, to make sure that this is within that realm, that it's pretty accurate. Basically, it may not get an accurate reading. You know, when you get very small, I was showing you, like, it's hard to get an accurate reading. Maybe some things have just been redrawn. Not likely. Usually things that are going to be redrawn would be done digitally, so it usually adjusts itself. But you never know. Those types of problems do occur. It's endless, the amount of problems you see that come up on construction. So always do things with a grain of caution, right? This is what I'm starting to get into when I'm talking about AI and use in construction and things. It's very good, but it also feeds you some confabulations that are filling gaps that might be problematic if you don't know what you're looking at. So you have to be a little bit cautious. NTS means not to scale. It's a standard. Like, designers they don't want to be responsible that you've scaled something. They're saying that's on you. You know, you find out from us if there is something missing. So it won't be their fault. It's not their fault, right? Even if they were neglectful at not putting a measurement, or even if something was out of alignment, you should ask, right? You should ask. So the onus is on you from that particular aspect. So I don't want anybody going away from this video saying, oh, okay, I can scale everything. Yeah, you could, like for measurements that you want to order things or you want to estimate things, or if there is some measurement that you know is not like really that important, but it's not on the drawings and you don't have the designer around and you want to basically get this going on, yeah, sure. But otherwise, you shouldn't be doing it from that perspective. But you do have the concepts now down and you understand the proportionate part. I'll put a link to the textbook in the description below. I will also tell you there's a lot of, like, there's well over 1,000 questions in the textbook. Those are very helpful for you to practice. That's how you really get good at reading drawings, is practice, practice, practice. Get used to looking at them. Get used to being able to figure out certain things, and you'll get much better from this stage forward. So looking forward to your comments. If you enjoyed this video, please click subscribe. It really helps to build the community. Comments are helpful as well. And I'll see you next time. Have a wonderful day. Bye for now.